All right, we're gonna be starting with 4.4, guys, adding and subtracting like fractions, least common denominators, and equivalent fractions. I'm gonna go ahead and give you guys about 4 minutes to set. I'm gonna give you guys 6 minutes on this slide to set up the title, the definition, and the method of how to solve, or not solve, but how to find the LCD. Go ahead and talk about this section. So we're starting chapter 4. You see the section titles and names. We're skipping a couple, 4.4. Remember, everyone, you all have access to the textbook on my math lab. So if there are other sections you want to look over as you're studying the class, you're welcome to. Like, let's say you're only taking this one class or two classes and you have extra time, open up the book and look. Oh, be like, why did Pacheco skip those? Oh, that's because it's basic. It's this, it's very simple. Oh, okay, cool. It's a lot of material out there for you. My math lab has like also videos as well. Like, there's a lot of cool resources on my math lab that I hope you play around with when you're working on your stuff. All right, 4.4. Adding and subtracting like fractions, least common denominator, and equivalent fractions. Definition is the least common denominator. So it is the smallest possible number that is divisible by all the denominators in the list of fractions. It is also called the least common multiple. Method 1. So how do you find the LCD of a list of fractions? Using multiples of the largest number. Step 1. Write the multiples of the largest denominator starting with the number itself until a multiple common to all denominators in the list is found. Step 2, the multiple found in step 1 is the LCD. Is everyone ready for me to move on, or is anyone still writing? All right. Here's example A and B. I'm gonna go ahead and give you guys 2 minutes to set up example 2 in your notebook before we move on, before I start working it out. All right, that was a 2-minute timer. So let's look at example A. Find the LCD of 3/7 and 5/14. Least common denominator is talking just about the denominators, the bottom values. So I know I said to take the largest value first, 14. And then, but we also want to list the other ones as well, so we can find the one that is common. And we want multiples, right? So multiples of 14 is just adding by 14. So 14 plus 14 is 28. 28 plus 40 is 42, and so on. And then we have 7, 14, 21, and 28. Notice that there's two common denominators that we see, right? We have the 14s, but we also have what, ladies and gentlemen?
The 28.
The 28s. But I want you to understand, what does the L stand for in LCD?
Least.
Least. So we want the least one from the two. So we're going to pick 14 and we're done. Okay. So I really didn't have to go after 14. I could have stopped at 14. I knew it was going to be 14, but I wanted to show you that there's going to be a couple of numbers that are actually also multiples of each other, but we don't care for just anyone. We want the least. All right, let's take a look at B. We have my two denominators, right? 12 and 20. I like to do the bigger one first because that's what the step tells us, right? Do the largest one first and then the smaller one next. So then from there, we're going to go ahead and do 20, 40, 60, 80. Now you can stop if you know what multiple it is from 12 that's going to hit one of these, right? You could stop, but if you don't, then just write out as many as you can. So then we go by 12s now. 12 plus 12, 24. 12 plus 24 is 36. 12 plus 36 is 48. 12 plus 48 is 60. And voila, right there, you guys can see that we have 60 as the common denominator from both the denominators. So that is my LCD. And this is the first method I'm showing you guys on how to do this one. Are there any questions on how to use this method to find the LCD? Any questions at all? All right, you're gonna go ahead and do it yourself with this practice set here. I'm gonna go ahead and give you guys 3 minutes to start with. Good luck. All right, that was the timer for the practice problems, guys. All right, so find the LCD of 7/8 and 11/16. Remember, LCD is the common denominator. We want the least one, and if you got 16, you got it correct. Good job. If you didn't, did anyone not get 16 and need some help on it? Anyone need help with the first practice problem before I move on? All right. Second one, let's see if anyone in the chat says something. Jennifer said LCD is 150 for the second one. Anyone agree or disagree?
Agree.
All right, let's see how everyone did. You are correct, Jennifer. Good job, good job, good job. Are there any questions on the LCD on how to find the LCDs of just two fractions, guys? Any questions? Good. All right. Now method two, I'm gonna go ahead and give you guys about 4 minutes to write this slide down into your notebook, guys. Let me know if I need more time than just 4 minutes, all right? Now is the second method of finding the LCD. All right, guys, that was a timer. Would anyone need additional time to write this before I move on? I'm going to read it through, type it in the chat if you need more time. So method 2, finding the LCD of a list of denominators using prime factorization. So step 1, write the prime factorization of each denominator. Step 2, for each different prime factor in step 1, circle the greatest number of times that factor occurs in any one factorization. All right, that's the keyword here, one. Step 3, the LCD is the product of the circled factors. Recall, a prime number only has factors of 1 in itself. So for example, I gave you the first 6 prime numbers we'll be utilizing 2, 3, 5, 7, 11, and 13. I am going to add another 2 minutes because some people ask for more time, guys. 2 minutes, and then we'll move on to the next set of examples. All right, let's go ahead and move on. So example, I'm gonna go ahead and give you guys 1 minute to set this up before I start working it out. All right. So now notice how we have bigger numbers now, right? So method one really wouldn't work for numbers like 72 and 60. So at that point, we have to try a new approach. The new approach is method two. We're gonna have to find the prime factorization of both these denominators and then pick out the pretty much follow the steps, right? So first we're gonna break down 72. 72. So we're gonna make a prime factor tree, guys. So start with the 72. I'm gonna show you how I do it. Or we're gonna do it together. Can anyone tell me any two numbers multiply that give me 72? Any two numbers that multiply?
72 times 1.
Good. Uh-huh. And then what's another one where one isn't a factor?
12 times 6?
12 times 6?
Uh-huh.
Yeah, 12 times 6 does work. 6 times 12. So now, because 6 times 12 makes 72, right? But guess what? What makes 6? 6 is 2 times 3. The moment you get to prime numbers, which is the numbers from the list here, you can stop and circle them. Now, 12 can be broken down to two other factors, right? 3 and 4. And then 4 is the same thing as 2 times 2. And there you go. We now have it all broken down. You have 1, 2, 3, 2. So 72 is 2 times 2 times 2. And it's 2 threes. 3 times 3. So now I'm going to draw a line and now I'm going to break down 60 now. What two numbers multiply give me 60?
6 times 10.
6 times 10. But 6 is also 2 times 3. So we're done with the 6 sign. What's 10?
5 times 2.
And these are both primes. So we're done. So it'll be 2 times 2 times 3 times 5. They're now broken down. Excuse me. Now, if you want to check your work, you can just multiply it out on your calculator. 2 times 2 is 4, times 3 is 12, times 5 is 60. We're good. 2 times 2 is 4, times 2 is 8, times 3 is 24, times 3 is 72. So we did step one. Write the prime factorization of each denominator. Boom, we did that. Step two, for each different prime factor in step one, circle the greatest number of times that factor occurs in one factorization. So let's look at the different primes we have. We have number 2, we have 3, and we have 5. So which one has more 2s? The 72 or the 60?
70.
72.
So we're gonna circle the 3 2s in 72. Because it's the greatest. That's what step 2 is saying. Step 2 is saying for each different prime factor, circle the greatest number of times that factor occurs in one factorization. Good. Now look at the 3s. Which one has more 3s? The 72 or the 60?
72.
The 72. So we're gonna circle the 2 3s in 72. And then we have 1 5. We have to make sure we include every different prime factor that we see in either factorization. And now this is how you get the LCD. The LCD is literally all the factors in the circles. So the LCD is going to be 2 times 2 times 2 times 3 times 3 times 5. Plug that into your calculator. 2 times 2 is 4, times 2 is 8, times 3 is 24, times 3 is 72, times 5 is 360. And we're done. Remember, notice how the negative didn't really impact us here at all. We're just focusing on the denominators. Are there?
So could we could have done it the other way? Like the other way you taught us, or can we
Yeah,
do it? You have to
yeah,
do this one.
no, you could have done it the other way,
Okay.
72, 144,
Yeah, like
22.
you times it.
Yeah,
Okay.
yeah, you can, but that's gonna take a lot longer. This
Longer,
is,
yes.
yeah,
This is just a little, the way, a shortcut, the way you do it. Okay,
yes, this is another method.
okay.
So, Monica, you're saying you're lost. What part lost you?
All of it. You're breaking these numbers down to get an answer to what? The problem?
Yes, I am showing you. So this is another method, Monica, method 2 of how to find an LCD.
Right.
It's another method. So step 1, you write the prime factorization of each denominator. Prime factorization is this right here. This whole thing, all this is prime factorization. This is the prime factorization of 72. This is the prime factorization for 60. The way you do this is by making a prime tree.
Okay.
I think it's what they're called. That's how I learned how to teach prime factorization. You start with the number, and then from there, you pick any two numbers that multiply that give you 72. And you keep breaking down each factor until they're prime numbers. And once they're a prime number, and the prime numbers are right here, 2, 3, 5, 7, 11. Once these are the only factors that come out, you circle them because you can't go any further. Well, you could, right? You could do 1 times 2, right? But that's just the
Right.
same thing. So you stop at 2.
That's kind of what I was just now thinking, because you could go one more step, but you're saying to stop at the prime number.
Yes,
It has to be a prime number.
has to be a
Okay.
prime number. Has to
Now,
be a prime number.
what is
I-
the 360? Where is that coming from? I know by adding all these numbers, the 2s and the 3s and the 5,
Multiplying
is
that.
that the answer to the problem up here?
Yeah. This is the
Okay.
LCD. The LCD is 360, and we're multiplying them, not adding. Just make
Okay.
sure.
Yeah,
Multiply.
sorry.
No, you're fine. And then yeah.
Okay.
Okay. So now that I explained it again, do you understand why we did the stuff to the right?
Yes, just probably by doing more, I'll get it. But yeah, I understand it somewhat.
Okay, no worries. Let's see. Let's give it a try. Okay. Here's a practice problem for you guys to try. 40 and 108. And Rosemary, I want you to try this method as well. You can do this. Okay. I know
Yeah,
the
I'm
other
gonna try it.
the other one does work. It does work.
Yes,
But I rather save your precious time. I rather give you more. This is why this technique is here for like when it gets difficult.
okay.
So try it. I'm gonna give you guys 4 minutes on this one. All right. And y'all can feel free to stop and ask me for like, hey sir, I'm here with this. Like, where do I go next? You know, like I'm here. So 4 minutes. I'm gonna give you 3 minutes. I'll add more time if I need more time.
How do you know you're using the right number when you like start the tree?
The cool thing about the tree, it doesn't matter which factors you start with because you just keep going down the levels on every factor. Like on the example, you notice how we did 6 and 12. I could have done 2 and 36. You could do whichever factors you want, but if they're not broken down to their prime, you just break down that factor further. You keep going. There's no right or wrong answer of where to start with. Okay. The biggest thing is to make sure that as long as they are factors.
Of both numbers or just the
Do one number at a time. 40 will have his own prime tree. 108 will have his own prime factor tree.
okay. Hmm.
Anyone need more time, guys? Would anyone like more time on this practice problem? All right, so you're ready for me to review the answer?
I'm gonna tell you, I got lost a little bit and I didn't get the answer yet. But go ahead and continue teaching because I'm a slow learner, so I have to do it several times for it to come into me.
No, no, Rosemary, you're fine, ma'am. You're fine. So
Okay.
did you do the prime factor tree for one of the numbers?
I only did 40.
Okay, you tell me how you did 40.
So I put 8 and 5.
Okay. Did you circle any of them?
No, I didn't circle any of them.
None of them were prime
No.
number? You sure?
Was I, sup- was
Look
I
at-
supposed to circle? Okay, I'm sorry. That's where I got lost then, I guess.
No, look. So remember, a prime number only has a
It's a
factors of one.
5.
There
Okay.
you go. So once you know it can't go any further, you circle that one. I'm not circling 8 because 8 has what other factors, Rosemary?
So I don't have to worry about the 8. It's just the 5 since it's a prime number.
The 5, yeah, well, you only have to worry about the 8. The 5, you're done because it's a prime number. You can't go any further.
Oh, okay.
But the
Okay.
8 is not a prime number. It can be broken down to 2 other factors. Which
So
ones?
I put 2 and 4, 2 times 4. And then
Good,
that's where I got my even number, which is a 2 for the 4.
good. You can circle the, why did I circle the 2?
Because it's a prime number.
Good. And then can I go, and the 4 can go further, how much?
Yes, 2 times 2. And that's right there.
I don't understand this.
What don't you understand?
I did 40 and then I did 4 times 10 and then I broke it down to 4 times 1 and
I
then
did the same thing too.
Ah, y'all did 4 times 1. Did you see me include 1 in this prime number list?
4
No.
times 10?
No, not for 4 times 10. Because Jennifer said she did 4 times 1.
it would be 2 times 2, right?
There you go. There you
And-
go.
I did for the 10, I did 5 times 2.
Let me show you why we don't do 1 and 4, because then we would get 1 times 4, and then this will get 1 times 4, 1 times 4. It could never stop pretty much. You see what I mean?
Yeah.
So so you never want to include 1. It has to be 2 and 2. Now, Melanie, you say you did 4 and 10,
Oh, so yeah.
Yes.
and did you get what we got?
Yes, I
Two,
got
two,
the
two.
same thing.
Perfect. That's excellent. All right. Does that make better sense, Jennifer, about switching it up from the 1?
Yeah.
Okay, good. All right. Anyone want to share with me what they got for 108?
I did 3 times 36.
108, 3 times 36. Yep, that works out. Can I circle any of them?
The 36.
36 is not a prime number, so it cannot circle that.
Oh, the 3.
No,
Is it-
it's not a
is it-
prime number.
3 is not a prime, you sure?
Oh,
What are
I'm not sure.
what are factors of 3?
Yes, it is a prime number.
Yeah.
It is a prime number.
So
So
now what's,
circle the 3.
and it was 36.
12 times 3.
12 times 3. And then what's 12?
4 times 3.
What's
Mm,
4?
1. Or 2 times 2.
And now let's write the prime. So it's 2 times 2 and then 3 threes.
How do you know when to stop?
When
There's a
you,
prime number, right?
yeah, when it's a prime
Okay.
number. Two, when it's a 2 or 3 or 5 or 7. When pretty much the only factors are just prime numbers.
So when you circle the prime numbers and when we stop, that's where we plug it in and we do 3 times 3 times 3, the way you have it there circled.
Yeah, so that's what we do it over here. So then it's gonna be 2 times 2 times 3 times 3, right? Is that what we got? 2 times 2, yep. You see 2, 2, 3, 3, 3.
Yes.
This is what makes our prime factorization.
Okay.
These are what makes the prime factorization. Is everyone with me, class? Because this is its own process itself. Step 1 is its own process.
Okay, so now how do we get the answer again from here? From
So
where
now that was step 1. Let's look at your step 2. Someone read step 2 for me for the class.
For each different prime factor in step 2, circle the greatest number of times that factor occurs in any one.
Thank you. Thank you. So we're gonna circle the greatest number of times you see a factor occur in one factorization. So we have the 2's. Which one has more 2's, the 40 or the 108?
the 40.
So we circle these 3. Now this one has 3's. So we'll circle these 3's because it has more 3's than this one over here. And I gotta circle one last one. Which one?
The
5.
5.
The 5, yeah, because it's different. We got one for every different prime factor we see. There's got to be a circle. Like if there is 1, 5 here, one of them has to be circled. You know, it all depends on each prime factor you see that's different has to be included. So then the answer, the LCD of this example, is gonna be 2 times 2 times 2 times 3 times 3 times 3 times 5. When you plug that into the calculator, you get release 1080. So if someone wants to double check the multiplication and let me know it was good, that way we can move forward.
Yeah, that's right.
Excellent.
Sir.
Yes.
Okay, so for 108, I used 9 times 12.
Uh-huh.
Okay, and then for the 9, to split that up, I have 3
3
times.
times 3.
Correct. And then, so do I stop right there
For the left side, you stop.
on the 3 times 3?
Yes, circle each 3 at that point because you're done. 'Cause you
Okay,
can't break those
now,
down.
right. So then for the 12, I have 2 times 6,
Good.
which the 2, I'm stopping there. But then the 3, I'm sorry, the 6, oh, I put a 3. Damn. It's supposed to be 2 times 3.
There you go.
And then that's where it stops.
And that's where we stop. Yes.
Okay.
Okay, let me ask you real quick. So why
Yes.
do we circle the 5?
Because we have to remember each step. Look at the rule. The rule step says for each different prime factor, prime factor.
I got it right there.
So for each different prime factor, okay. So for every different number we see, so 2, 3, 5, 7, for every number that comes out in our prime factor,
yes.
we need
Okay.
to include it.
Okay, I got it. I got it. I got it. Thank you.
Awesome, awesome,
Sorry.
awesome. No, don't apologize. Sorry that my aggressiveness is just from the excitement of talking math. That's all it is. All right.
I'm sorry, Mr. Pacheco. I need to ask again. Because
No,
I'm trying
of
to
course.
figure
Go
this
for it.
out.
Go for it.
Okay, so my prime numbers, again, you have 2, 1, 2, 3, 3 2s, and then 3 3s, and a
1,
5 for 108.
Yes.
Correct?
Yes.
Okay. I have, the ones that I have circled first are the 2 3s, and then 2 2s, and 1 3.
Are you on the 40 and 108? Oh, okay. You're talking about your, are you talking about your prime factor tree?
Correct.
So from your prime factor tree, Monica, you want to make the list here from least to greatest over here. This is where, in this area over here. This is what I'm
Okay.
doing here. I wrote my, look at the 40. 40 had 3 2s, 1 2 3, and 1 5. So you see 2 times
Correct.
2 times 2 is 5.
See,
And
I
then for
got
the,
that one.
so you have your list there, and then you do the 108. 108 is equal to 2 times 2, and then 3 times 3 times 3, just like the tree down here. Okay, you with me?
Well, I'm missing a 2 and a 5.
Well, no. We're not doing the LCD yet, Monica.
Oh,
Right now we're doing the 40 and the 108. Do you have these two listed on your paper?
yes, I do.
And you have it like the way it's up here.
No, I have it still on I'm still on the tree on 108 because I'm trying
So-
to figure out how you got that many and I got the different one.
So look, on your tree, as your
Hey,
108,
guys.
does your 108 tree look like, do you have 3 2 2 3 3? Do you have that in your tree for 108?
I have 3 3 2 2 3. Remember, I said from 108, I went
Uh-huh.
down to 9 times 12.
Uh-huh.
And then from the 9, it's 3 times 3,
Yeah, so those are 2 3s. Yep.
right? And then from the 12, it's 2 times 6.
And that's your 1 2 right there. Uh-huh.
And then from the 6, because I can't do anything with the 2, I got 2 times 3.
There you go. So circle that 2 and 3.
I did. And that's where I stopped.
And there you go. So at that point, you should only have 2 2s and 3 3s.
Correct.
Okay, good. So now all you gotta do
You
is just
have-
list, you just gotta write it out, Monica, as a list now. So you gotta have 108 and write out your list. So how many twos was it? It was 2 2s,
Two
2
twos.
times 2, and then 3 3s. 1, 2, and 3.
Okay.
And then your 40 was 3 2s and 1 5.
Correct.
Okay, you're with me in there.
Right.
So now to get the LCD method 2, we have 2 different 2s here. We have 3 2s and 2 2s. But step 2 wants you to, for each prime factor, circle the, which one?
The greatest number
Of what? Of
Of times.
times that factor what?
occurred.
So which one occurred more? The 2s with the 40, the 2s with the 108.
The 2s with the 40.
So circle the 3 2s. That's where these 3 2s come from, right here, from the LCD.
Got you.
Now remember, we want to have a circle for every different prime factor. So how many different prime factors do you see here? Different types. We have,
I see 3.
yeah, we have 2s, 3s, and 5s, right?
Correct.
This 40 doesn't have any 3s, so we're gonna just circle these 3s here because they're the only 3s that we have here. That's these 3s right here.
Oh, okay. Okay, so
now-
we're combining them then.
Yes, we're pulling from each one to make the one for both of them. This number that we're creating will be the LCD for 40 and 108. And we cannot forget the what? The
The
5.
5.
And that's where the 5 comes from. Now, look at it. It was 1,080. If Rosemary wanted to do it the other way, she would have to gone from 40, 80, 120, 160, 200,
Yeah.
all the way
That's a
to
long way.
it's a long way.
I ain't gonna do it that way.
No, I know, but I remember you had said if you had meant yes,
Yes,
you had asked
yeah.
if you could very much do so.
but
that-
yeah, that's a waste of time. Too much time.
Too much time. Time is precious in life.
Yeah.
So everyone with me on how we pulled together the factors to get the LCD.
Yes, thank you.
Excellent.
Carlos.
And here is a helpful hint. All right. I'm gonna go ahead and give you guys about 3 minutes on this slide. And if y'all need more, let me know. And I'm loving the questions, guys. I do not be afraid to speak up. You don't get something. Like, this is why I am your professor, to help bridge you from the knowledge you need. All right, anyone need more time on this slide before I move on? Okay, cool, Melanie. Let me know when you're good to go, ma'am, and I'll move forward, okay?
She's done.
Excellent, thank you. All right, example. Let's look at example, find the LCD of 1/15, 5/18, 53, 54. So I'm gonna give you about 1 minute to set up A before I move on, before I start working out on A. All right, A, find the LCD of 1/15, 5/18, and 53/54. Remember, we want the LCD, so we're only gonna focus on the denominators, guys. So I'm gonna go ahead and list them out right here. We're gonna need to break down 15. What are the factors of 15? What's the prime factorization of 18? And what's the prime factorization of 54? So then to get the LCD, we'll get all of the components here and put it here. So then let's start with 15. What two numbers multiply give me 15?
3 times 5.
3 times 5. And they're both prime factors. So we're done here. So that's 3 times 5. Now we're going to go ahead and do 18. What are factors of 18?
2 and 9.
2 and 9. But 9 can be broken down to 3 and
3 and
3.
3.
So there you go. We have our next one. We have 2 times 3 times 3. Now we're going to go ahead and do 54. 54.
9 times 6.
9 times 6. 9 is 3 times 3. And 6 is 3 times 2. I'm only doing it quicker because we've done it before already. So that's 1, 2, and 3 threes. Now, you gotta look at it. How many different prime factors do we see in total? So we have 2s, we have 3s, and we have 5. So does it matter which 2 we circle?
No,
Because they're both the what?
a prime.
Yep. So I'm gonna circle the 2 with the 18. Now, which one has more 3s? The 18 or the 54?
54.
Circle the 3 threes. And then what else? Last but not least, which one should I look at?
The 5.
5.
Excellent. So then to get the LCD, ladies and gentlemen, will be 2 times 3 times 3 times 3 times 5, which equals 2. 2 times 3 is 6, times 3 is 18, times 3 is 54, times 5 is 270. And we're done. Any questions so far? So it's pretty interesting that this technique, the prime factor, it works with multiple fractions, not just two. That's what's so cool about this technique is that it actually helps you do it for multiple. Let's look at B, all right? B has denominators 5x and x cubed. Well, guess what? 5 is already a factor, so we just write 5. X is by itself, so we can just write x. And x cubed is 3x's, right? So now the two different factors we have here are 5 and x. Well, we have 1, 5, so we're going to include that one, 1, 5. And then we have 3x's in total. So my LCD will be 5 times x times x times x, which is just going to be 5x cubed. And we're done.
So with the 1x, we don't do it because it's a prime, right?
With the x, we don't, well, remember, the step says we want to pick each prime factor that's presented to be the most in any one factorization. If these both had x's, I only circle this x, these x's, because there's more here than this one. But these are two, they're the same variable, but different, quantities because this one's cubic.
Because it's like, okay, I got it.
If it was like a y, like instead of x, then we will circle the y because it's a different factor. And it would be 5x cubed times y. You know what I mean? Let's see how you guys figure out what this practice set, all right? I'm gonna go ahead and give you guys about 5 minutes. Good luck.
Mr. Pacheco?
Yes.
Okay. So for the 20 problem, you would stop at like the 2 and the 2, right?
Say that one more time.
So I did 20 and then I drew the lines.
Uh-huh.
4 times 5, and then
Mm.
you'd stop at the 5 because it's a prime number, right?
Correct. Uh-huh.
And then for the 4, it would be 2 times 2.
Yep. And that would be your prime factorization for 20. 2 times 2 times 5. Thank you, OJ, for sharing with the class the different factors. All right, guys, that was the timer. Does anyone need more time to work on it? The answer for the first one is 120, guys. And the answer to the second one is 11y. So if you got these values, good job. Now I have a question. Catherine, I'm not understanding your question. Can you reword it? You have a question, the parentheses on each fraction has to be solved like that, or it's just solving different. What are you asking, ma'am? Okay, okay. Yeah, okay. I'm gonna wait for the next class. All right. Everyone good with 120 and 11y. Everyone comfortable with that? All right, I'm gonna go through. Okay, yeah. Do you want me to work out the first one? I'll work out both of them. Okay. So, anyone need me to do the prime factorization tree, or are y'all cool with me writing the factors? Or do y'all want to see the process of getting the factors? Okay, let's do the tree for 24. So for 24. So it doesn't matter which factors you go with, as long as you don't start with 1 and 24, right? Because that's just going to be redundant. So it could do any factors of 24. Anyone want to share with me what they use for 24?
8 and 3.
So 8 times 3. 3 is a factor, so we can a prime, so we can circle 3. 8 is not, which is 2 times 4, which is 2 times 2. And voila, we have our prime factorization. 2 times 2 times 2 times 3. And now we got to do 60. So 60 is anyone. Remember, it's a practice problem, so I'm not going to
10,
work it
10.
out.
6 times 10.
6 times 10. And 6 is
2 times 3.
good. And 10 is,
2 times 5.
yep. So then we have 2 times 2 times 3 times 5. Now that we have the prime factorization for all my denominators, I'm going to find out the step 2 now. Which has the most 2's I'm going to circle?
24.
Which 3 can I circle? Does it matter?
No.
Now, which 5 can I circle or it doesn't matter?
No,
So it's gonna be 2 times 2 times 2 times 3 times 5. 2 times 2 is 4, times 2 is 8, times 3 is 24, times 5 is 120. And we're done. Let's look at the second one. The second one is 11y. So we have y and 11. Well, y is just by itself, so we can read it there. And 11 is a prime factor already. So we just circle these, and the LCD is just 11 times y, which is 11y. And we're done. What questions do we have on these practice problems before I move on?
Mr. Pacheco, can you move your screen up like just a tad?
Sure thing.
Thank you.
Did that explanation make sense, OJ, Josh? Any questions on my prime trees or anything?
Okay, so I must be doing something wrong again because for the total, I'm getting 240.
So you have an extra 2 somewhere.
I have 2 times 2 times 2 times 3 times 5. Okay, let me redo that then.
You have you said it correctly, right? So you only said 3 2s, right?
Yeah.
Yeah. So
Oh,
just,
you know what? Yes, I was doing it wrong. God. Okay. Sorry
Abe,
about
no, your work was great. Your computation was the mistake. So that means your knowledge is better, but your computation was just rusty. You're good.
Yeah. Thank you. I got it. I was adding the extra 2 in the calculator.
There you go. Good catch. All right, let's move on. All right, this is the last section we're going through, guys. And since we're not really gonna have an entire class, I'm just gonna start it through. I'm not gonna give a breakout. If I knew we're gonna teach until 4 o'clock, I would give a break, but we're just gonna go ahead and push through this lesson. I'm gonna give you about 2 minutes to set up the title and the examples so I can work it out. Let's take a look at example A. 3/4 x equals -1/8. Interesting, right? It's a and the cool thing about this is you can actually solve this using your properties, right? You can divide both sides by 3/4. And but then at this point you're dividing fractions and it gets a little messier. So I'm gonna show you a technique that I love to show to my high school students. And it takes a while to catch on, but once you catch on, it is a blessing. All right, so let's look at A. So we're gonna solve for X, right? But we're gonna solve these equations, guys, but we're gonna get rid of the fractions. And the way you get rid of fractions in an equation is you want to multiply the whole equation, the left side and the right side, by the LCD. Now looking at A, guys, what do you think the LCD is from 4 and 8?
2.
What? Now that's Uh, mm, not necessarily correct. Remember, at LCD, the numbers can divide into it, and 8 and 4 cannot divide into 2. It's too small.
4.
Remember, it has to be for both of them. It's just like example 1 from 4.4, the last lesson we just did. Which number can 8 and 4 both divide to evenly?
Is it 16?
Now, let's see. I'm getting different answers. So we're gonna go ahead and do the multiples, right? I'm gonna show you how to use the techniques we learned last lesson. So we have 8 and 4. So someone said 16, right? So 8 and 16, but let's look at 4. You have 4 multiples of 4. 4, 8, 12, and 16. Now 16 is on there, guys, but what does the L and LCD stand for?
Oh, the slowest.
The lowest. So what's my LCD? Is it 8 or 16? 8. Everyone see that so far?
Yeah.
So we're gonna multiply this equation by that. So I'm gonna erase this because I wasn't trying to show the work for that because we know how to find LCD now. So we want to make sure we're applying the techniques we're learning in this class. Now, if you need reassurance, that's fine as well. But it's very important that we stay with the pace. So we're gonna multiply 8 times the whole equation. So it's gonna be 3/4 x equals -1/8. So we're gonna distribute this 8 to the left side. There's only one term, so there's only gonna be one arrow there. And then to the right side one time, because there's only one term there. Because we're multiplying the whole equation by 8. So then we're gonna get 8 times 3/4x equals 8 times -1/8. Now, the reason why we're doing this, guys, is since we know 8 and 4 divide into 8, it's gonna smoothen out. Let's talk about how, right? Now, 8, we're multiplying it to a fraction, everyone, right? So let's go ahead and make 8 into a fraction. And the way we multiply fractions is the top with the top, bottom with the bottom. So top with top. 8 times 3 is what, y'all?
24, I think.
Correct. Over the bottom times the bottom, what's 1 times 4?
4.
Excellent. X equals top with the top. What's 8 times -1?
8, -8.
Good. Over +8. So now we're going to simplify. When we simplify, there should be no fractions left. If a fraction is still there, we made a mistake somewhere. So 24 divided by 4, that's 6x. -8 divided by 8 is -1. And voila, this is the same equation as we started off in the beginning of the example. But isn't it much nicer to look at as opposed with the fractions? So now we're not done. We have to solve for x. So how can anyone tell me how to move the x to get 6 x alone? How do we move the 6?
Negative, I mean, -6.
We subtract?
Divide.
Divide. And then we get x is equal to -1/6. And we're done. So this opens the world to us that we could have solutions that are fractions, guys. Now, it doesn't say for us to check our solution, but just know if we wanted to check it, we just plug it into the original. Any questions on the steps that we took for A?
A lot of steps.
Now, if you want me to, let me show you how another way we could have simplified. This is the longer way because I didn't want to confuse anyone because I did the shorter way last class and it was interesting to say the least. It threw off a lot of people. Like for example, you know how 8's on top and 4's on the bottom, class? Well, how many times does 4 go into 8? 8 is the same thing as 4 times 2, right?
Correct.
Right. So that means these 4, since we have one on top and one on bottom, they can cancel out. And what are we left with? 2 times what?
3,
Which is just what?
6. There you go.
Oh,
And then here we have an 8 on top, 8 on bottom. So guess what? They can both what?
cancel out.
Cancel. And what are we left with?
1.
Look at what we had here. I just did this extra step to show you the math of simplification of how another way to simplify. All right, and we're gonna go ahead and look at B now. Okay, I can try the shortcut version to see if y'all follow with me. But if you cannot follow the shortcut, just multiply it out. Top with the top, bottom with the bottom. Does that make sense, everyone?
Yes.
All right, I'm gonna give you a moment to write down B. The first thing we have to do with B, guys, is find the LCD. That's the first thing we gotta find. So LCD. So look at the two different denominators. My two denominators is 6 and 3. Can y'all tell me what my LCD would be for 6 and 3?
6.
6.
2 and 3. Oh.
Good. Everyone with me that it's 6.
Yes.
Okay, good. So we're gonna multiply the whole equation by 6. X over 6 plus 1 equals 4/3. Now, there was only 2 arrows before because there's only 2 terms, right? One on each side. But now we're gonna have 3 arrows since we have 2 terms on the left side. Everyone see why I drew this many arrows? So then we're gonna get 6 times x over 6 plus 6 times 1 equals 6 times 4 over 3. Now let's simplify together. Shortcut. What happens to my 6's on the left side, the left term here?
Multiply them.
We multiply them, but since we have one on top and bottom, they're gonna what?
Cancel out.
Yep, and we're left with what?
X.
X. Now I'm gonna skip some steps so to show you this, we could have just made this into a fraction and we would have gotten 6x over 6, which is just x. Does everyone see that?
Mhm.
I'm going this way. So this is where we're at. Now, what's plus, right? Plus, what's 6 times 1?
6.
Now, look at the 6's, the 6 times 4 over 3. Now, how can we rewrite 6 with the 3 to cancel out the 3? What's 6 equal to? Can we take out 6 from 3 or 3 from
Yeah.
6? Yeah,
Yeah.
right? 6 is the same thing as 3 times 2, right?
Yeah.
So what cancels out?
The 3.
And what are we left with?
2 times 4.
Which is what?
8.
Yep. Now, let's say you didn't want to do that way. What if you didn't want to do the shortcut, right? Then you'll just make 6 into a fraction. 6 times 4 is 24 over 3, which just divides into 8 again. Is everyone with me?
Yes.
How do we get x alone then? How do we move the plus 6 over, guys?
Add 6 to the other side. Yeah.
Add. Okay, I heard add. Anyone agree, disagree?
Did we subtract?
It'd be subtract. Because to manipulate equations, we want to do the opposite. Is that understood?
Mm-hmm.
8 minus 6 is 2, and we're done. Now, what questions do you guys have on finding the LCD or multiplying it out? Any questions so far? Because you're about to try some practice problems in a bit. All right, let's see how you guys do. I'm gonna go ahead and give you guys 4 minutes on these 2 practice problems. Good luck. And you can always ask for me for help or talk to each other about it. We have. Did I say 4 or 5 minutes? 4.
And
I'm gonna give y'all, let me see what people said. 4. Okay, I'm gonna give y'all 4 minutes and I'll give y'all more time if you need it. Good luck.
Mr. Pacheco, I have a question.
Yes.
Um, when we get to the part where it's 15 times -3 and then the over 5, would
Mhm.
you do 15 times -3 and then put it over the 5?
Yeah,
Okay.
that is correct. And then you would just divide the negative number on top, divided by the +5, and get your result for the right side. All right, guys, that was the 4 minute timer. Anyone need more time to work?
Yes.
I'm gonna go ahead and add 2 more minutes, guys.
It's Candy. I knew I had a bad vibe off that guy in that blue car.
All right, guys, let's look at the solutions for these two guys. For the first one, we got -9/11. And the second one we got is 10. In the chat, I noticed that's what people are getting. So good job, class. Are there any questions about these practice problems before we move on?
I don't understand the second problem.
Yeah, and I actually got lost on the first one.
Okay, so let's talk about let's look at the first one. What did y'all get for the, remember, these are practice, so I'm not gonna leave these. I'm gonna just go based off of students' responses. So what did y'all get for the LCD?
I got
15.
15.
Correct, that's good. So then you're gonna distribute that to both sides, right? Let me write down, so it'll be 11/15 x equals -3/5. Distribute your 15. Equals 15 times -3/5. So now we have to simplify. What happens to the 15 on the left side?
We exit out.
And then we just have 11x. And now here we got and now remember, if you don't know how to break it down, you're gonna do it the old school way. You're gonna do the top times the top, bottom times the bottom. And I'm not gonna do the shortcut on this one just because. So multiply. What's 15 times -3? 15 times -3.
It's 45.
What kind of 45?
-45.
Good. And then we have 1 times 5, which is just what?
5.
5. Now divide that. What's -45 divided by 5?
It's -9.
So then we get 11x equals -9. How do we get x by itself? How do we move 11?
Can you pick your screen up?
Yeah, thank you.
Thank you.
What was the question? I'm sorry.
How do we move the 11 to the other side?
You divide by 11 on both sides.
You divide by it because it's being multiplied. So we divide. That cancels out. So we get x is equal to -9/11, and we're done. Any questions? All right, for the second one, what was the LCD?
8.
The LCD was 8. So we're gonna multiply the whole thing by 8. When I distribute the 8 to the whole equation, how many arrows am I gonna draw?
3.
Correct. So we get 8 times y/8 plus 8 times 3 over 4 equals 8 times 2. What happens to the 8 with the y?
You would put the 1, but since we're not doing that, they cancel out, so you'd have y.
Good. Now what's the second one? 8 times 3,
27 or 24, I think. I don't know. Hold on.
24. 24 divided by 4.
6,
Good. So this is 6. And then what's 8 times 2?
16.
Now, how do we move the plus 6 over?
You would subtract it by 6 on both sides.
And 16 take away 6 is 10.
Yeah, 10.
And we get y. And we're done. Any questions on these practice problems?
No.
All right, let's move on. So in this one right here, solving an equation, pretty much what they're saying is they're gonna add another new step to it, where step 1 is just multiply both sides of the equation by the least common denominator of the fractions, guys, if it's present. All right. So let's go look at the final examples here.
We didn't have to write that down, right?
No, you did not. All right, I'm gonna give you about a minute to set up example A before I work on it. So it's the same concept as before, guys. Same example as before. So as you're writing that, we're gonna need to find the LCD. So if you finish writing this down before the minute, try to find the LCD on your own. Method 2 will be really easy to find the LCD. You already have the 5 and 3 are both prime factors already. So all you have to do is just multiply them to get the LCD. All right. What did you get? What do you think the LCD would be for 5 and 3?
15.
Say that one more time.
15.
That's correct. So we're gonna multiply the whole equation by 15. Now, before I do that, does anyone have any questions how I got the 15? Is that we just use the same steps that we learned earlier in this lesson in 4.4, or actually in this lesson. No, last lesson actually. Okay. So go ahead and draw your arrows. Remember, the objective, guys, the point of us finding this LCD is when we multiply to these fractions, we're supposed to just have whole numbers at that point. That is the goal of us doing this.
Okay, I did that right. Never mind.
All right. So let's go ahead. I'm not going to do the shortcut just because I don't want to lose people. So I'm going to make 15 into a fraction. So then we look at it. So it'll be 15 times z, right? It's 15z over 1 times 5, which is 5. And then we have this second fraction here. 15 times z is 15z. And we do 1 times 3, which is 3. And then we do 15 times 6, which is 90. Now we're going to simplify. How many 5s go into 15?
3.
3. How many 3s go into 15?
3. I mean 5.
And voila, we have a new equation without fractions.
So would we add the z's and then that would be like a negative or no?
Yeah, combine them. You owe me 5, but you have 3, so you still owe me how much?
-8.
So if you owe me 5 and you paid me 3, because you had 3, it's a positive 3.
2, -2.
Negative 2z equals 90. And how can we get rid of the negative 2, guys?
Divide it on both sides.
Divided by both sides. And 40 divided by -2 is z is equal to -45. And we are done. What questions do we have on any of these steps? It's the same as before, but I just went a little more detail on the simplification step. So you can see it's simplified to whole numbers. All right, let's go ahead and finish off the B example. What do y'all think the LCD is for B when the factors are 2 and 3, the denominators? What do y'all think 2 and 3 go to? Or divided to?
6.
Yeah, 6. You're right. You just multiply them, right? It's 2 times 3, right? That's correct. So we got that part. So we're gonna multiply 6 to the whole equation. X over 2 over equals x over 3 plus 1 over 2. I'm going to distribute that. All right. This one, I'm gonna do the shortcut part where I want you to see the exposure of that, okay? So over here, we have 2 in the bottom, right? What factors multiplied 6 to have 2 in there? 2 times what is 6?
3.
So I'm gonna scratch out the 6 and put 2 times 3. What's gonna cancel out?
2.
And what are we left with?
The 3.
3 what?
3x.
Excellent. Now here we have 3 in the bottom now, so 6 is the same thing as 3 times 2. What's gonna cancel out here?
The 3.
Good. What are we left with?
2x.
Excellent. Same thing here, 3 times 2, but what cancels out?
The 2.
And what are we left with?
3.
3 times 1, which is
3
just,
times 1 is
3.
3 plus 3.
Y'all with me? So now all we have to do is solve for x. How do I move the 2x to the other side with the 3x?
Divided by 3.
Well, we want to
Oh.
move this 2x, so we're gonna subtract because the opposite of positive 2x is negative
Okay.
2x. So because we already have an x over here. This is 0. Bring down to 3. What's 3x take away 2x's?
1x.
1x.
1x, and we're done. What questions do we have on this one over here? All right, ready for your last practice problems, guys? Anyone still writing before I move on? All right, here is your last set of practice problems, guys. I'm gonna give you 5 minutes. Good luck. I'm gonna step out and get some water. I'll be back. All right, class, I'm here in case you have any questions.
Mr. Pacheco, I think I'm getting lost on,
Which one?
okay. So for the first one, I did 5 times x minus x equals 5 times 1. Because I did like to distribute or whatever, and then I put 5 over 1, x over 5 minus x equals 11. I mean, x equals 5 times 1, and then over the 5. Then I
Now,
got 5,
I didn't hear the middle part. So after the 5 times x over 5, what did you say in the middle? Minus what?
5 times x again.
Okay, okay, cool. Okay, so then what happens when you simplify?
When I simplified, I got 5x.
Start from the left side, this left fraction. What happens to the fives?
They cancel out, so it just becomes x.
Good,
And then I put 5x minus 5x
good. Equals what?
equals 5 over 5,
Which is, what's 5 over 5?
1.
There you go. So it equals to 1.
Oh, that's it?
And then now you just gotta solve for x.
Mm.
Just keep in mind, class, the multiplying the LCD is in order for us to get rid of all these fractions. That way we can just have an equation without fractions. Now the solution may have fractions, but now we can solve this. Combine x minus 5x. What do we get? What's x minus 5x? You owe me 5, but you can only give me 1. So now you owe me what?
X
Well, how many x's?
negative 4x.
Negative 4x. Good. Equals 1. And how do we get the negative 4 to the other side?
Divide it.
Yep. And x equals negative 1/4. You got it right. Any questions on the first practice problem, guys? Any questions at all? Excuse me. Okay. Any questions on the second one, guys? The solution for the second one, you should have gotten 5.
I got lost since it was like backwards, and then since the answer was a fraction. So the only thing I was able to do is 10y over 5 plus 30 over 2. And then
So let's just hold on. Let me catch up with you. So I'm gonna multiply the 10, right? Distribute it. So you get 10y over 2, right? Times equals 10 times y over 5 plus 10 times 3 over 2. Well, 10 over 2 is what?
5
5 what?
5y equals 2y plus 15.
Yeah. Now
And
just,
then
just solve for y.
2y,
How do you move the 2y over?
it becomes negative 2 or subtract.
Yeah. Subtract 2y or negative 2y, same thing. Potato, potato. And then you do minus 2y on both sides.
So that would be 3, and then you do
3y equals 15. And how do we get the 3 to the other side?
divide it. So then it's 5. Y equals 5.
Y equals 5. Yeah. Oh. Yep. Y equals 5. Does anyone have any questions, guys, so far? On these slides or in these practice problems? Any questions whatsoever? All right. If there's no questions, guys, this does conclude the lessons for today. Since I am giving you more time on the homeworks and test one, you guys, you're able to go look at that. Monica, you can stay on the line so I can go over that one question from the test you had issues with. As for everyone else, guys, as soon as I'm done with my session with Monica, I'm gonna go ahead and assign you the homeworks from today's lessons, and that way I can have some practice on 4.4 and 4.8. Any other questions before I dismiss the class? Oh, let me take roll call real quick. If you do have any questions, please put it in the chat.
We have a oh, sorry. Never mind.
All right. Isabella. Alina.
Here.
Chris.
Here.
Jasenia. Jasenia, are you online, ma'am? Yes, you are. Okay, cool. Jennifer's here, LJ's here, Monica's here. Sean,
Here.
excellent. Gabriela,
I'm here.
Marcos here, no Damien, no Isaac, Savannah,
Here.
Melanie,
Here.
Alyssa, Matthew, Vicky, Alex,
I'm here.
Catherine,
Here.
Jose, Rosemary,
Here.
Joshua, and Ariel.
Here. I'm here, sir.
Appreciate you. Ariel's here too. Awesome. I got you, Melanie. Yeah, you're here, ma'am. You're good. All right. Good job, guys. All right. Attendance is good. Oh yeah, Jennifer, you say you had a question too. No, I got you, LJ. You're good. Okay, bye, Vicky. Have a good day, guys. You are all dismissed unless you have a question for me, which I know it was Jennifer and Monica. If anyone else have a question, let me know. You can type it in the chat. I'm gonna go ahead and help you out first, Monica. Let me pull up my math lab real quick. Let me go ahead and exit these out.
Yeah, I'm trying to find the assignment.
Now you won't be able to access it on my math lab, but do you have it written down in paper?
Well, I was looking for it because I wrote all my questions down
Excellent.
as but I don't remember exactly the numbers. I know it had the answer it was like reversed. Let's say it was supposed to be 30y times 5 or something like that, right? What n equaled? Well,
I'm
I
looking-
put n equaled
Uh-huh.
5 times 30y or something or other. It was
So-
backwards, but it had the same numbers.
So I'm on your last question. It says translate the following sentence. It says solve the equation 30 subtracted from 3 times the number, right?
Okay,
And it's supposed to be equal to, so there you go. So your answer, you put 30 minus 3x. But read the sentence again. It says 30.
I don't
sub-
have, I can't.
Oh,
open it.
oh, sorry. Okay, let me share this window of the test. So you
Okay.
can give me a second.
So there is a mistake in there, as always, those little mistakes. And I do that a lot. Ugh.
Okay, can you see the last question? This one. This is the one you're talking about, right?
Yes.
So this is the right answer. It should have been 30 subtracted from 30 subtracted from. So I told you, hey, Monica, can you subtract that 30 from the 100 you owe me? So then you wouldn't do 30 minus 100 to give me the number you owe me. It would be 100 minus 30. So when it says subtracted from, that
Mhm.
means the 30 needs to be after this part. So you put 30 minus 3x, where it should have been 3x minus 30. Because you got the right side right, x plus 2, you got that right, component correct.
Okay,
And then from there, you got the wrong solution since you had the wrong equation.
okay, so it does matter where we put them. as far
Subtraction is the only operation, and division. Those
Okay.
two are the only one that matters the order. Because 2 divided by 1 is 2, but it's not the same thing as 1 divided by 2, which is 1/2. So subtraction and division are the one, because 1 minus 2 is -1, but 2 minus 1 is +1. So order of a subtraction and division matter.
Okay. Well. Okay, I
Hey,
got it.
but you have a high B though. You have a high
Ah.
B, which is great. And I don't know how extra credit works, if I can offer it. I have a meeting with my department chair this week. If I know I can, I will. If I can't, you won't hear me announce anything, but you're doing
Okay.
amazing, Monica, okay?
I appreciate that. Yeah, that one just, and it like bothered me all week. And I just like, oh my God, why and why did I get it wrong? But that makes sense now.
All
Okay.
right. And then was that your main question, Monica, so far?
That was it. Just like I said, that one really got